Dear students, hope you all are doing well. This video is for class 9 and today we shall study rational and irrational numbers. So directly jumping over rational and irrational numbers, let us have a look on our number system. See, the complete number system is divided into two types. One is imaginary numbers and other real numbers. In our syllabus, we put more focus on this real numbers. But let us have a look on this imaginary numbers also. See, if I write root 4, what is the answer? Maybe plus 2 or minus 2. Plus 2 into 2 is also 4. Minus 2 into minus 2 is also 4. If I write 9, answer may be plus 3 or minus 3. Okay. But what if I write minus 4? What is the answer? 2. 2 into 2 is not minus 4. If I write minus 2, then also minus 2 into minus 2 is not minus 4. So such numbers are called as imaginary number. If I write minus 9, what is the answer? Such numbers are called as imaginary numbers. So this was all about imaginary numbers. Now let us come to the real numbers. So before going to real numbers, just have a look on the different type of numbers which we have studied in the previous class. See here. First, we have natural numbers. So, you know very well, all counting numbers are called as natural numbers. For example, 1, 2, 3, 4. And the set of this counting numbers is denoted by the letter N. Next, we have whole numbers. All counting numbers means natural number. Along with natural number, the 0 is included. So, these numbers are called as whole numbers and this set is denoted by the letter W. Next, we have integers. In this, you can see natural numbers starting from here 1, 2, 3 and also 0 means whole numbers. Further, it is proceeded further. See, minus 1, minus 2, minus 3 means positive numbers as well as negative. So, these are called as integers. Integers denoted by I as well as Z. It becomes very easy. Natural number N denoted by N, whole number W denoted by W, integers I denoted by I. Students always stick to this I, but once in exam Z was asked and the students were confused. So please keep this in mind. Integers are denoted by I as well as Z. In this integers, you can see there are no fractions. So, when we place this integer in the form of fraction, what are they called as? They are rational numbers. See, for example, you can see 3 upon 5. 3 is integer. 5 is also an integer. So, these are integers. Minus 5, integer, negative integer, upon 8, this is positive integer. So, rational numbers are also expressed as terminating and recurring. Terminating means you know very well when the when the remainder is 0 means further we cannot divide. So such numbers are called as terminating, and recurring means when the quotient is repeated. So rational numbers are also expressed as terminating and recurring. But the easy form to remember this rational number is we write the rational number in the form of P upon Q. P is also an integer. Q is also an integer, where your Q is not equal to 0. This P can be 0, P can be negative, but your Q cannot be 0 and your Q cannot be negative. Let me explain this. See, fractions you have studied, you know fractions very well. This divided into 4 parts, 4 equal parts. So, equal parts we write in the place of denominator. From this 4 equal parts, I have colored one part. So, 1 you wrote in the numerator. It means 1 upon 4. Out of 4 parts, 1 is colored. Take this example of cake. 1 piece I have cut. So, from 4 pieces, 1 is cut or 1 is eaten, whatever. The fraction became 1 upon 4 means out of total 4 parts, 1 is cut. So, this is possible. See here also in this. Out of 3 parts, 2 are colored. Means how many total parts are there? 3 parts. Out of 3, 2 colored. What if there are no total parts? So what can you cut from this? What can you color from this? Because the total parts are only missing. So your denominator cannot be 0. Your numerator can be 0. See, for example, this one. See this example. How many total parts are there? 5 parts. Out of this 5 parts, nothing is colored. So you have written 0 here. So this is possible. Out of 5 parts, nothing is colored. So this is possible. But the other case, this is not possible. So we say that rational numbers are expressed as P upon Q, where your Q is not equal to 0. Now see, P upon Q, this is right. 3 upon 5, this is your P, this is Q, this is possible. This is also P upon Q, integer, P upon Q. But what about this? Is this rational number? Yes, is this rational number? See, 0. Where nothing is there in the denominator, then we consider as 1. So now this became rational number. This is numerator, this is denominator. Denominator is not equal to 0. What about this? Is this rational number? Yes, why not? Nothing is there in the denominator, then we take the denominator as 1. Now again this became rational number. Numerator, denominator is not equal to 0. Take one more example, minus 8. Is this rational number? Nothing is there in the denominator, means we have taken denominator as 1. P upon Q, where Q is not equal to 0. Numerator can be negative. Okay, so these are rational numbers. Let us see some properties of rational number. What are the properties? See, when the sum of two rational numbers is always rational. When you add these two numbers, such kind of number, the sum of two rational numbers always rational. The difference of two rational number is also a rational number. The product of two rational numbers is always rational. When a rational number is divided by non-zero rational, we always get a rational number. So these are the 4 properties of rational number. Now next let us come to irrational numbers. Irrational numbers means other than rational number. See, here the rational numbers are denoted by letter Q. So irrational denoted by Q dash means other than rational numbers. Rational numbers are expressed as terminating and repeating, recurring. So irrational numbers are expressed as non-terminating. The division will not stop. And non-recurring. See, for example, here you will go on dividing the number, but you will not get a recurring. 1.30, 3 came, but after this you got 20, 3 came, but 30. It will not stop and the numbers will not recur also. So such numbers are called as irrational numbers. For example, we have root 3 means all radicals. This root sign is called as radical. So all radicals come in irrational. Root 5 irrational, and the non-terminating and non-recurring numbers also come in irrational. Also pi is an exceptional case, but pi is also considered as irrational numbers. So this was a briefing about rational and irrational number. Hope you have understood this. We will continue this in the next lecture, next video or next session. Thank you very much.